Hello, my name is Sumanth, and I'm here to talk about a topic that is very close to me personally and something that I've derived through my years of experience as a software engineer. I'll be talking about the building blocks of intelligent software engineer. What I mean by that is the process or the components required for building applications that are driven by data and enhanced by artificial intelligence. In that course, we'll be able to establish a software development life cycle that can be incrementally and iteratively improved upon by a constant influx of data and AI, and thereby making an AI-enabled SDLC. I'll be talking about a few different things today. So we'll start off with a couple of examples of how artificial intelligence has manifested into applications and concepts that we're all familiar with. We'll be talking about pain points in applied AI, where software development teams and data scientists and companies overall face in adopting and scaling AI into their applications. We'll also be talking about primarily a few different building blocks that contribute to the success of scaling and adopting AI into software applications. And these are primarily derived from my own experience as a software engineer. Lastly, the building blocks that we'll be discussing today are technical building blocks. The success of those kind of technical building blocks are largely dependent on the support they get from organizations. So we'll be spending a small amount of time on talking about organizational building blocks that contribute towards the success of these technical initiatives. We'll be ending with some conclusion remarks, and we'll also have some time for Q&A at the end of the session, should anybody have any questions. Let me first introduce myself. As I mentioned, my name is Sumanth, and I've been a software developer for the last 20 years. I have worked with companies in the healthcare IT space, e-learning, e-commerce, management consulting, and clinical pharma and IT. And throughout my experience, I've worked with companies in building data-driven software applications that are high volume and high demand and high availability applications. I have learned many lessons during that course of time, many failures and some successes. But overall, I've been a strong proponent of building efficient software applications that are reusable, have a small footprint, but are primarily intelligent. My initial efforts in building intelligent applications have mainly been rule-based and condition-based. But during the course of time, I have slowly embraced the idea of AI, and now I consider myself an AI evangelist that strongly recommends making AI an integrated part of software engineering. I'll talk about a personal example, a personal experience of mine before we get into the rest of the presentation. So a few years back, I was working for a company where we were building an analytics component to an existing application. We spent about 18 months and close to $2 million in developing that component. But at the end of it, we ended up with probably 25% or a fraction of what we actually wanted to do. It was considered a costly failure, but not because nobody put in any effort. Everybody did a great job. But the failure was primarily because the inherent complexity in an effort like that. Software development and AI are both complex fields, and they require dedicated focus. And if we lack some of the benefits of the building blocks that we talk about here, the success rate of such efforts are likely to be very low. So before we get into the pain points and the building blocks, here are a couple of examples that I'm going to talk about that show the prevalence of AI in day-to-day use. So the first example is frictionless authentication. We are all familiar with authentication when we're trying to use our mobile applications, web applications, or any other form of application. And what we are all most familiar with is a user and password-based single-factor authentication. We also, over the last few years, we've also come across two-factor and multi-factor authentication, where applications are trying to identify you and make you prove that you are who you say you are. This is great in terms of improving security, but what it does is a disruption in the tasks, especially when you have to do this several times during your workday, constantly disrupting your work. So many research organizations and companies have been investing efforts in coming up with a frictionless authentication, which focus on behavior and attribute-based authentication. The benefit of that is that it won't compromise security, but it'll provide a seamless experience for users, and essentially a frictionless authentication process allowing you to continue doing your work efficiently. The second example of prevalence of AI is user engagement broadly. And what I mean by that is there's a huge amount of digital platforms that are focused on retaining or increasing user engagement across their user base. The users could be online learners if it is an e-learning application. It could be employees if it's a workforce application. Content consumers in applications such as Netflix, YouTube, and Amazon Prime, or e-commerce platforms where they're trying to retain existing customers, or digital marketing where they're trying to find and convert new customers. In all of these places, companies are trying to understand users better and provide them services more catered, more personalized to them. Much of this analysis can be considered as descriptive and diagnostic, where it's trying to understand what happens today and what happened yesterday. But there's also a significant amount of effort in trying to understand what can happen tomorrow, or what might consumers want in the very near future, so that they can cater their products and services more aligned to their customers or their employees. This kind of an effort is easy for large organizations like Amazon, Facebook, Apple, Google, Microsoft. But when it comes to small companies or small organizations, they are still trying to make small inroads into these efforts, and more or less trying to reinvent the processes on their own, which delays the process of adoption of AI, or worse, it can lead to incorrect or inefficient implementations. So what are those challenges that the small companies face when it comes to implementing AI? The first and most talked about pain point is the need for high-skilled expertise. Data science is an expertise that requires a high degree of knowledge in processing data and understanding data, and it is a skill set that many software engineers don't possess. So, in essence, you have software engineers that are very good at building applications, but not so great data scientists, and you have data scientists that are great data scientists, do a great job understanding data, but not software engineers. So during that process, we have created this silos of teams that only focus on one aspect or the other. It is very rare to find a software engineer that's also a great data scientist, unless they have spent years of experience in following both the fields. And that kind of a skill set is rare, which adds to the problem of smaller organizations not finding the right skill set to achieve their goals. The next pain point is this emphasis on model development versus platform improvement. A lot of emphasis placed on is building different kinds of models for different kinds of use cases, but not enough thought is put in place to understand what that model, once deployed to production, will need, and what will be required to make it successful in a live environment. What that leads to is, one of the reasons that contributes to that failure is a tightly coupled AI application. Basically, what that means is, because of the limitation that we've talked about before, what happens is software developers and data scientists come together to build an application that is very closely coupled with the AI model, and expects a finite set of use cases. And that creates a tightly coupled AI implementation that is bound to fail in a live environment because it cannot adapt fast enough to changing conditions. And that leads to the next pain point, which is because of this kind of a tightly coupled implementation, the platform itself that the AI model sits on lacks the ability to learn from real world feedback and feed that into the retraining or refining of the AI model. The next pain point is performance driven development, where applications need to be built for performance. It is very common nowadays to have a huge volume of data. A customer of ours is looking to scale up to 1 billion data points per day generated during the course of this year. So applications that software applications in general and applications that want to benefit from AI have to keep that in mind when they are building their frameworks. They have to be performant and they have to be able to handle volumes of data. Many companies may not need that kind of volumes, but if there is one fact that we can establish today, it is that the amount of data that's going to be collected is only going to go up and not down. The next pain point is application interactivity. Many applications today are still remnants of legacy applications, legacy monolithic applications, which are finite sets of closed implementations. You can pull off implementing artificial intelligence in such applications, but maintaining them, enhancing them, or scaling them up is going to be a challenge. So it is very important to build applications that are smaller in scale, but more modular, and hence give the ability to expand or scale up based on the need. The final pain point is related to democratization of AI. There's two components here. There is a good amount of repository of AI models that are available that address different use cases. For example, understanding the diseases that through chest X-rays, or understanding teeth alignment. However, the same cannot be said about implementation of AI models. So what that leads to is every software development team goes down the path of taking an AI model and implementing it on their own, creating multiple versions of implementations across, where no one person achieves the perfection of implementing an AI model, but everybody has some version of it. And this creates a race for who can build an AI model, solving for the same problem in a different way. Some companies are trying to address this problem. A company that I've recently come across is a company called Artris, which has recently made available its implementation of AI models. And the companies that are our software development teams that want to leverage some of the problems that Artris has solved can use their platform to incorporate into their own applications. So we've talked about all of these pain points. I think the next topic that I'd like to talk about is the building blocks. Let's get into the building blocks. I have 5 building blocks, and let's talk about the first one. So the first building block is about continuous data collection. We know that there's a high variability of types of data that we can collect today. For example, we have real-time data that can come from your social media channels, clickstream data from your different types of applications, transactional data that is coming from your web and mobile applications, and sensor-based data coming from your IoT applications. You also have data that can be called batch data sitting in your databases, your CRMs, data warehouses, and media and document repositories. Many organizations that I've worked with or I'm aware of have the same collection of data, but most of the data is sitting in silos in different repositories, and there is no cohesive structure where the data can be extracted and collated to form a foundational layer for further analysis. So the first building block is to make sure that you have a process in place, a framework in place to extract data from all of these different data sources using connectors, and then collect them and collect them in a data repository that can then be used as a fuel for artificial intelligence that you will be working on later. So that would be the primary goal of this building block, which is ensuring that you have the right kind of fuel to create the right kind of intelligence for your application. The second building block is continuous data analysis. So I'd like to start with an example here. So let's take an example of sentiment analysis, right? This is an example where you can have an input text string, either a voice to voice converted text string or a straight text string generated by a user. And the purpose of the sentiment analysis model is to extract the underlying sentiment in that text. It can be a product review, it can be a customer complaint, it can be a customer feedback, but the idea is the same, which is to extract the sentiment. You can achieve a good result in a constrained environment where you have a finite set of text inputs. But when you're dealing with an e-commerce application that can scale up to millions of users, you could be having hundreds of thousands of users putting in feedback or some kind of an input into the applications in real time. Trying to implement a sentiment analysis model on that kind of data volume is a challenge. And what many companies are able to do is go back in time, look at the data collected, and then perform a sentiment analysis. But then doing that in real time is another challenge itself. That's where the Lambda architecture comes into picture, where it solves for that problem, where building up from the previous step, where if you are able to collate the data into a data repository, in that process, as you're collecting the real-time data, you can implement analytical models that analyze real-time data and provide the results to any kind of querying mechanism. Either it could be your application, or it could be your customer service personnel, so that you can provide real-time feedback to your internal processes. This also accounts for batch data analysis, where you can go back in time and perform a historical analysis of the data. So the second building block is ensuring that you have the right mechanism for implementing continuous data analysis, both for real-time data and also for batch data, which then feeds into your next step of building the intelligent processes that contribute to your application. And the next block, which is something that I consider as very important, is an event-based architecture for your application. Applications today are built, or many applications are built with a finite set of assumptions about the type of behaviors they expect from the users, or the type of features that they think are important to their users. What that does is we end up building modules that run based on conditions and parameters, and we in the process either we create a monolithic application or a service-based application. But in the end, it still has a limits on its flexibility. There is a way to address that problem, and that solution is this event-based architecture. If you look at every action that happens in an application as an event, and every module that creates that action, or that is responsible for that action as an event producer, an event consumer, or both, we would be able to establish this foundation of a message-based architecture or event-based architecture that can then help with the scalability of the application. So events and producers and consumers contribute to building up a knowledge graph of activities, where this knowledge graph is actually derived from the real life conditions of that particular domain. So this level of architecture has two benefits. One, it implements the foundation for scalability of your application, but it also helps you in building up a knowledge graph that can be highly useful in providing input to your learning models, your artificial intelligence models, and provide for a real-time feedback loop based on the knowledge graph. So the next building block that we talk about is going to be a workflow and rule-based architecture. With the event-based architecture, we hopefully will be able to provide a level of abstraction where every event and every action contributes to the scalability of the application. With the rule-based and workflow-based architecture, we can take those events, those exact events, and apply a rule framework on top of each event that can produce further events that can have their own rules. With this, what we achieve is, if If we achieve scalability with the event-based architecture, we achieve flexibility with the rule-based architecture, where you can now, in the process of developing your applications or using application, you can identify new conditions, you can validate existing rules, and you can identify new events that need to be put in place, contributing to the growth of your application. This is also the perfect opportunity where you can introduce your AI engine, where your AI engine can either validate the existing rules that are occurring, which then feed into improving the AI, or it can create new opportunities for rules that you learn from your AI model, and then overall improving your architecture. This is also a place where you can reuse your knowledge graph in validating some of the assumptions that you made before, or more importantly, you can assign weights to events and actions in your knowledge graph, and thereby identifying like which are the more weighted events or more important transactions that are happening in your application. The goal of this particular step is to build an adaptive application that can react to real life situations and provide you with an opportunity to modify your application without having to make large changes in your application. Next, we talk about the final building block. So this building block can be called a summary of the previous four building blocks, but it also talks about a very important concept. We talk about something called highly cohesive and loosely coupled architecture. That's a very contradictory statement, but it has a very good meaning in the context of software development. Software applications should be built as a collection of modules that operate very well independently, but also work very well when they're brought together. If you're able to satisfy these two conditions when building an application or after having built an application, you have achieved a level of maturity in your application that very few companies have achieved consistently. A good example of a company that has achieved this kind of maturity and implemented it successfully is Amazon. If you look at AWS, it's a collection of different services that work very well independently, but also work very well together. Now, with this architecture, the way modules and components interact with each other is through the process of through the availability of APIs or microservices. These APIs are not only available to your internal needs, but these APIs can also be made available to outside entities or the outside world. With the introduction of AI, what you can also take an opportunity of doing is expose intelligent functionalities through API to the outside world. And that allows you to provide the intelligence that you have gathered through the data that you have collected to the outside world, which then directly contributes to the democratization of artificial intelligence. Companies can now focus on solving unique use cases that they come across instead of trying to solve for use cases that have already been solved by somebody like you. And then create a collaborative environment where we are all contributing to the collective growth of artificial intelligent applications. So that is the building blocks that we talked about. Now, as I mentioned before, we also talk about a few different organizational building blocks, where we talk about where companies can contribute towards the success of the technical building blocks. Some of the main things that companies should focus on is having an intelligence strategy where they incorporate the ideas of intelligence right from the very initial concepts of software engineering. Companies should have a comprehensive data strategy to make sure that there are no siloed data stores or huge volumes of dark data. Companies should also focus on providing enough support from the leadership and also governance to make sure that the AI being developed is unbiased. People-centric outcomes is very important, where companies should focus on building outcomes that are tangible and directly beneficial to their user population, be it their employees, customers, or outside users, so that the motivation to continue focusing on AI is not diminished. Finally, planning for scale is very important, where where companies should not look at AI as just a series of pilot projects. They should be planning for implementing AI on a large scale, and make sure that that's what they're planning for, and build efficiently. Finally, I'd like to talk a little bit about myself and my company. So I'm the CEO and founder of Quality Data Machines. It's a company that was founded in 2018, and we are based in New Jersey. Me and my team collectively bring an average of 25 plus years of experience in building high demand, high availability data-driven applications. And then it's our mission to provide data intelligence as a service to companies. With that, we hope that we provide a platform for companies to adopt and scale AI at a lower cost and lower effort compared to what they would be able to do on their own. If you have any questions, please feel free to reach out to me or my colleague, Mike Fowler, who heads the commercial operations, or please visit us at our website, politics.com. I'll also be available at the virtual booth to answer any questions. But hopefully we'll have some time here to address any questions the audience might have. Thank you.